Sorry, I don't know what happened. It was internet issue. So I was asking which questions should we go through on question 1.
Part B.
Okay. But if at all we are good to go, we can ignore the corrections and maybe we proceed with calculations of equations. Okay, let's look at part B. Sodium hydrogen carbonate. So in this case, you should first try and write the formula first. So if you look at our sodium, has valence 1, hydrogen carbonate is our radical, it also has valence 1. So that means our sodium hydrogen carbonate will have this formula here. So when determining relative atomic mass or relative formula mass, we shall have to add all these atoms. So when we start with sodium, we shall see that sodium, the relative atomic mass of sodium is 23. It wasn't given, probably, but it will always be given. However, it's only one atom, so we shall say times 1. Plus hydrogen, 1 atom. Relative atomic mass is 1 times 1. We go to carbon. Carbon has relative atomic mass of 12, and it's only 1 atom, 12 times 1. And then lastly, oxygen has 16 times 3, because there are actually 3 atoms. So we shall have 23 plus 1 plus 12 plus 48. 48 plus 12, 60 plus 24, probably 84. So our relative formula mass will be 84. We shall not put grams in this case because we are actually talking about relative. When something is relative, in most cases, the units cancel out. So in this case, we shall just leave it at 84 as our answer. So that's how we can determine sodium hydrogen carbonate. Yes, Chigundu. Chigundu, unmute yourself and share with us one other number. You can guide me through the process. We have A, C, D, E, or F. You can choose one and take me through it.
Iron 2 sulfate.
Okay, you choose iron 2 sulfate. So iron 2 sulfate, okay. You can guide me, I'll do the writing. Yes, you go. Yes, someone to choose for us something and give it a try. Yes? Oh, we are good to go. We can go to another number. If at all, we are all good to go here. Yes, Ahawa, are you good to go? Although I thought Ahawa should be in A.
Yes.
Okay,
Yes.
are you running away from your stream? Okay, so.
No, I'm supposed to be in the stream.
Okay, sorry. So in your free time, try out A and see how the pentahydrate comes about as well. So since you are saying we are good to go, I will jump to that conclusion. Then we have question 2. In this case, you are given number of moles. Remember, we talked about moles. moles are just like any other unit of measurement, whereby if we talk about a mole of a substance, we shall always be having a certain number of that substance. So if we're talking about maybe atoms of carbon, we shall have this number of atoms. If you're talking about molecules of oxygen, we shall have this number of molecules, and that will be 1 mole. For example, if I say that 1 mole of oxygen gas contains 6.02 times 10 to the power 23 oxygen molecules. However, if I'm saying 1 mole of oxygen atoms, it will also contain this number of atoms. So I'm right to say if I have 1 mole of oxygen molecules, I actually have 2 moles of oxygen atoms. Who can see that? If I'm looking at molecules where we have 2 atoms of oxygen, if I'm looking at 1 mole of oxygen gas, I'll have 6.02 times 10 to the power 23 oxygen molecules. But if I'm to look at that 1 mole of oxygen molecules, it will actually contain 2 moles of oxygen atoms, because each molecule contains 2 atoms. So always whenever we talk about moles, we are referring to a certain number, which is Avogadro's number, 6.02 times 10 to the power 23. And last time we said how they obtained it. They just had to put carbon onto a weighing scale. They had to place carbon onto our weighing scale. This side they put 12 grams. And then this side they had to place our carbon. But basically carbon 12, remember carbon has isotopes. Basically they placed on our left-hand side carbon 12. And when our beam leveled, it was meaning that we have equal masses. So they had to determine the number of atoms present in this carbon, which weighed 12 grams. And the number of particles of atoms determined, they discovered they are 6.02 times 10 to the power 23. That's how they came up with that Avogadro's number. However, when you look at our question, number of moles, whenever you are given relative atomic masses, always these ones are equivalent to the mass of 1 mole. For example, if you look at sulfur, this is usually a yellow powder. So if you get your yellow powder and try to weigh it, if your reading shows 32 grams, you'll be having 1 mole of sulfur. So these numbers here, the ones equivalent to the atomic masses of these elements, will be the masses of a mole of that given element. So in this case, I can say 1 mole. Let us do this one of silver. So our silver has 108, weighs 108 grams, 1 mole. So I can say if I have 1 mole of silver being equivalent to 108 grams. That means I can also say 180 grams of silver are equivalent to 1 mole. Now, if 108 grams are equivalent to 1 mole, what about 1 gram of silver? What do you think it will be equal to? Rodney, what do you think will 1 gram be equal to?
(108/1).
108/1, right? Okay. So what about this one, Rodney? If I have 108 books, cost 1 million. What will 1 book cost? Yes, Rodney. Share with us. What will 1 book cost?
1 million divided by 108.
Yes, it will be the 1 million on our right hand side divided by the 180. Obviously, the 1 million divided by the 180 books times 1 book. So the books will cancel out. So in this case, we shall have our 1 mole divided by 108 times 1. So this is for 1 mole, for 1 gram, sorry. However, they are asking for 21.6 grams of silver. So that means 21.6 grams of silver will be equivalent to this mole for 1 gram times 21.6. So we shall have 1 over 108 times 21.6 moles. So the answer you get will be the number of moles in 21.6 grams of silver. However, you could also do it in shortcut form if at all maybe you are dealing with objectives. We know from our theory about when we are calculating empirical formula that number of moles can always be obtained from this formula here. We get the mass given, the mass of the substance given, divided by the relative formula mass, or the relative atomic mass in this case, because we are looking at an element. So we shall have the mass given is 21.6 divided by the Rfm of silver, which is 108. So you realize that this and this are actually the same. So either way, you arrive to the same thing. Although this will be common in practicals, whereby they will need you to go through the actual steps from first principles than using a formula. So if you have to look at maybe ammonia, we can use the formula in this case. Mass given is 6, so it will be 6 divided by the Rfm. Now, in this case, because ammonia is a compound, we shall have to divide by the Rfm, but not the RAM. Relative molecular mass, or relative formula mass. So in this case, we shall have to find the mass for ammonia. Nitrogen is 14. Was it given? It wasn't, but nitrogen is 14. Plus hydrogen is 1 times 3, which is 3. So this is equal to 17. So we shall have 6 over 17 moles of ammonia. So that's how you'll be doing the other questions as well. Please let me know if you are still finding a challenge, because you'll be doing these things when we are looking at the equation bit, when we are trying to compare products and reactants. You'll be converting grams to moles unknowingly. So let me know if we are fine here. Or you are tired? Are you guys tired? We are having a long online session. Any challenge so far? Please let me know.
No?
Okay. So we now have question 3. I will also do 2 questions here, and then you will be required to do the rest. So which ones can I look at? Video to Google Classroom. I think it will be too heavy for me to send a video lesson to Google Classroom. That's the challenge. Normally they are heavy, I think. That's why we rarely send them. Okay, calculate the percentage of nitrogen in each of the following. Ammonium chloride. Which one should I do? A up to D. Which one did you find challenging? Yes, Jason. Yes?
D.
Which? D, C?
D.
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 Oh, okay. We do D. Calculate the percentage of water of crystallization in sodium carbonate crystals. Okay. So you might have heard about water of crystallization and efflorescent substances. Sodium carbonate is an efflorescent substance because it will always lose this water of crystallization whenever it is exposed to the atmosphere to form sodium carbonate, and the 10 water will be released. However, they want us to determine the percentage of this water in our compound. So let's try and see what we shall need. So basically, we shall need the following. We shall need the mass of water of crystallization over the relative formula mass of the crystals. The Rfm of the compound then times 100. That's all we need for us to get the percentage of water of crystallization. So let's find the Rfm of sodium carbonate. So we know that Rfm of sodium carbonate will be equal to the atomic mass of sodium is 23. At least this one, in this case, it was given. However, we have two atoms, 23 times 2. Then plus we have carbon, but we have one atom, so it will be 12. It wasn't given, but at least maybe we shall get to know it. 12 times 1, then plus oxygen, which is 16 times 3. Then plus water. Now, water already has hydrogen and oxygen. Hydrogen times 2, it is 2. 1 times 2. Plus oxygen, 16 times 1, it is 16. So basically, water we shall have 18. So if we have 10 water molecules, that means we shall have 10 times 18. You can do it the other way around. You can first find for hydrogen, you can say hydrogen alone, we have 1 times 20 because there are 20 atoms. Plus oxygen, we have 16 times 10. 20 plus 160 will be 180. So either way, you get the same thing. So this 180 is the mass of our water of crystallization. So I can write it in our formula from here. We have 180. So now we're only left with finding the Rfm. Someone to press for us a calc and we see the values. This is 60, 106, 100 plus 180, 286. Is it 286, I guess? So Rfm will be 286. Still, I'll not put grams because it is actually relative formula mass. But if I call it molecular mass alone or formula mass, I can put grams. So we have 286 times 100. So the answer you get will be percent. Any challenge so far? Let me know. Any challenge so far?
Not yet.
Okay, so can you try in your free time C, B, and A, or there is one you'd love to see me do with you? But this is basically addition. As long as you can interpret the formula of the compound, that here we have 8 hydrogen atoms and 2 nitrogen atoms, we shall be good to go. So should we leave question 3 and go to 4, or there is something you feel we need to look at? Okay, we proceed. Okay, Alan, when you look at ammonium sulfate, Alan, unmute yourself, Alan. Yes, Debuni.
Yes, sir.
If you look at part C, can you help us identify how many atoms of each element present in ammonium sulfate? Can you kind of tell we have maybe 7 nitrogen atoms, 4 hydrogen atoms, 7 sulfur atoms, and so on? Is there a way you can tell? Because for you to find the RFM, you should be able to interpret the formula of the compound. Yes, Jed. Jed, share with us part C. Just identify how many atoms of each element, and then we proceed to question 4.
Part C, there are 2 nitrogen atoms, and there are 8 hydrogen atoms. Then there is 1 sulfur atom and 4 oxygen atoms.
Okay, let me hope everyone can see what he has seen. Then lastly, question 4, I'll do part A. Part B is similar to part A, and then probably part C if time allows. And then when we meet again on Wednesday, hopefully, we shall have to proceed with our mole concept. We shall look at how we can relate compounds and reactants, sorry, products and reactants. So part A, I think we already seen this, but I'm sure most of you may not have done this work. How many tried it out? So let us have a look at the elements, the ones we are having. The elements we are having in this compound X, we have carbon, we have hydrogen, and oxygen. So whenever you are given 2 percentages, you have to show the working on how you obtain the 3rd percentage. Don't do it only with your calc and be like, it is done. You have to show how it comes about. Otherwise, you might lose a mark. So 100 minus 40 plus 6.7. What do we get? 46.7 minus 100 times -1. What do you get? We get 53.3. So remember last time I told you, if you are given percentage, you are indirectly, we can assume that indirectly you are given the mass. So that when we are finding the number of moles, at least we have seen that number of moles is equal to the mass given over the RAM. So, sorry, number of moles. So if you look at this compound X, if at all maybe we had 100 grams of compound X. If compound X has 100 grams, it means for hydrogen to be 40% carbon, sorry, for the compound to be 40% carbon, we must be having 40 grams of carbon. And then 6.7 grams of hydrogen, and so on. So that's why we can use the percentage and divide it and consider it as mass. So 40 as our mass over our RAM of carbon, which is 12. Then hydrogen, we have 6.7 over 1, then 53.3 over 16. So number of moles is equal to mass given divided by RAM or Rfm. If we are looking at a compound. So we have number of moles. What do we get? How many moles do we get? At least this is 6.7. The Boone. What do we get? How do you get? Anyone with the calculator? Yes, Martin.
3.33.
You get 3 points. .33. So at this point, you can see that in this compound of 40% and 6.7, you realize that whenever you have, we shall be having something like, for carbon, 3.3 moles, while for hydrogen will be 6.7. So still you are seeing the ratio of carbon to hydrogen is kind of like times 2. However, for us to get this good ratio, normally we divide through by the smallest, because that helps us get a good mole ratio across all the 3 elements. However, even from here, you can see that this one is almost double these other ones. So we shall divide through by the smallest so that we can easily get a good whole number. So 6.7 divided by 3.3, 3.3 divided by 3.3, 1, 1, 2. So basically the ratio of these elements will be 1 to 2 to 1. And with this, we can easily get our relative formula. Sorry, the empirical formula. We shall get the empirical formula. And this will be C1H2O1. However, they're asking for the molecular formula, the actual formula of the compound. This is the reduced form, simplest ratio for each of the elements. But we know that if you have the empirical formula and multiply it by a certain non-zero and non-negative number, whole number, this will always give you the molecular formula. However, whenever you have a molecular formula, maybe if you have something like calcium sulfate, you always have the mass of that given molecule. If at all they have given you the masses of the different elements. So in this case, they have given us the relative formula, the relative molecular mass is 60. Relative molecular mass is 60. Yeah, we can say relative formula mass or relative molecular mass. It's the same thing. A formula of a molecule, you know. So relative molecular mass is 60. That means the molecular mass is 60. So we can say that we have CH2O times a certain number will always be equal to our 60. So carbon is 12 times 1, which is 12, plus hydrogen is 1 times 2, which is 2, plus oxygen 16 times 1, which is 16. So 14 plus 16, that is 30. N is equal to 60. That means our N will be equal to 2. So for us to get the molecular formula, we are going to come back to this equation here. So we shall have CH2O2 because our N is now 2. That means our molecular formula will become C2H4 and then O. So that's how we can determine the molecular formula of compound X. C2H4O. So when you look at this other question, that means you can give it a try. Percentages have been given. They've given you for carbon, and they've told you it's a hydrocarbon. So you should identify the second element missing and show the working on how you obtain the percentage. Then they've given you the molecular mass of the compound. After finding the Rfm, you will equate it to 78. So after finding the empirical formula, you will equate it to 78 by multiplying it by a certain constant N. So I think you'll also try part C. I feel it's not so unique. Empirical formula of a compound formed when 2.4 grams of a hydrocarbon. Okay, they have given you carbon and forms 2.4 of a hydrocarbon. Okay, let's do this. I think it's a bit unique. Any questions so far? Please let me know if you are a bit lost. Let me know. We should make use of this time, because once physical classes start, we may not have the same time. Yes, Hash, are we together? Some of you, I wish there was a way of checking whether you are robots right now. Some of you are robots. Once you sign in, everything else can't wait. Okay, so let's look at this one. They're talking about empirical formula of the compound formed when 1.8 grams of a carbon forms that. So carbon, we are having it as 2.4. Sorry, hydrocarbon is 2.4 and carbon is 1.8. So that means the elements we're having carbon and our hydrogen, because they're talking about a hydrocarbon. So carbon alone is 1.8. So if we shall be finding the number of moles, we know that our carbon, the mass is 1.8 grams divided by the Rfm of carbon, which is 12. Then we shall need to show the working for our hydrogen. We shall need to get the mass of the hydrocarbon, 2.4 minus 1.8, which is what? 0.6 probably, 0.6 grams. So our hydrogen will be 0.6 over relative atomic mass of hydrogen, which is 1. So we shall have 0.6. What do we get for 1.8 divided by 12?
Zero point one five.
We shall get 0.15.
1.5.
So for us to know the actual ratio, we shall need to divide through by the smallest. Mole ratio of carbon to hydrogen, what will it be? Well, actually, this question might be much more tricky than this, so I didn't want to go through it. What is the smallest number of moles here? If you divide through by the smallest. Yes, Jason.
This one is 0.15.
Okay, so shall divide through by 0.15. Obviously, this is 1. 0.6 divided by 0.15, that's a 4. That means our empirical formula, please, this is not abbreviation, it's just to save time. Carbon is 1, C1, H4. So we shall be forming our methane. However, okay, I've asked for empirical formula, so we stop here. Empirical formula will be CH4. So there's no difference with percentage, whether you're given grams or percent. Either way, we'll just use the values given to find the number of moles. So here, just perusing through. If at all I see nothing is challenging, to have even 1 minute less, best. Okay, we're going to stop here, guys. I'm sure you can complete these other ones. Please have a nice day. See you when I see you again. Bye-bye. If you have a question, you can ask the remaining seconds. Okay.